Right. So moving on with the presentation. First, we would like to introduce our company, PowerSys Solutions, as you can see on my screen. PowerSys Solutions, if I move on to my screen, basically what we are is a consulting and software company. We provide global solutions for engineering software and services to industry, research and education in the field of electrical and electromechanical power systems. So basically, what we do is we provide solutions and services both on the EV side and on the grid side of the spectrum. So we would like to ideally, characterize ourselves as a complete solution for electrification. So basically, we deal both software distribution and engineering services in fields of electromagnetics, power electronics, multi-physics system level type of analysis, CFD, and power systems as well. So as I said, in brief, what do we do is we provide software and services, engineering consulting, and we do support research and development. To briefly talk about our company's existence across the globe, we are distributors of several softwares. Basically, our headquarters is in France, and in US, our headquarters is in Detroit, Michigan. And we do have offices across the globe in North America, specifically in Canada and California, in India, and also in Germany and France as well. So our company dates back to 18 years. We are close to 2 decades of existence with over 50 employees across the globe. And in specific, in terms of North America business, we operate from two regions. One is in Michigan and one in California. So in California, we have offices in San Diego and San Jose. And in Michigan, we are located close to Detroit in a city called Rochester Hills. And looking at the portfolio of our softwares, as I said, we are a provider of complete solution for electrification. Our spectrum ranges from electromagnetics to power electronics to power systems to system level type of analysis. And as you can see, the spectrum of software is shown here. And specifically today, the concentration is on our FEA software tool called JMAG. And also our customer base, we do have over 2,000 customers across the globe, and some of the important customers are mentioned here on my screen. So coming to the topic of today, as I said, today we are going to present the simulation technology tool for electromechanical design, which is JMAG. And the topic for today will be new functions and features in JMAG version 19. So beginning of this year, we have released the latest version called version 19. And we will be discussing about some of the key features and some of the new functionalities which have been implemented as part of this release. Also, today's speaker will be Sainan Shu. She's our senior EM design and support engineer. And she does carry over a decade or 10 years of experience in automobile industry. Coming from vast experience, she will be discussing more about some of the functionalities and her experience in using these features. And if in case you have any questions, you can always post it on here, or you can also write us to our support email, which is jmagsupport@parsys-solutions.com. And the website, also Siren will show you a little bit, is jmaginternational.com to find some additional resources. So with that, I would quickly, before passing on to the speaker for the day, I will quickly play a 1-minute video to give a brief overview about our company. Okay, thank you very much. And I will pass it on to Simon, who will be taking over to present some of um, the topic for today.
Hi, Ved. Can you hear me?
Yes, Simon, I can hear you.
Okay, sure. Okay, and then now, thank you, Ved, for your introduction. So this is Ainan. Nice meeting you all online. So this presentation, other than the new features, it also includes 5 demos, so stay tuned. And in this new version, JMAG has evolved to become a tool that enables you to explore a vast design space with speed and ease. Number one, by changing your model's parameters and evaluating results in the simple two-window interface. That will be one of the demo later. Number two, JMAG introduces a rapid topology optimization algorithm. This will also be shown in the demo. Number three, JMAG is able to speed up your models, ranging from small and middle size up to large scale calculations. And first, let's check out the solver improvement. For your small and medium scale multi-case scenarios, the overall calculation time per case has been reduced. So this graph shows just how much time has been reduced relative to the number of elements of the evaluated case. It is not only the analysis that takes less time, but the input processing and reading of the results have also been reduced. The effect of this speed up is especially beneficial for large multi-case small-scale analysis using 2D models. And the speed of the highly parallel calculation solver has been improved too. This graph displays the speed up rates for several models, each having about 1 million elements. The improvement is the most significant at 256 and 512 cores. At 256 cores, the solver now achieves an average of 100 times speed up compared to a single core. Although usually 3D analysis tends to be the focus of the use of parallelization, the recent improvement will also benefit your large 2D analysis. The mapping using the multi-purpose file export tool has been sped up. The drive for increased accuracy in multiphysics analysis comes generally with the increase in model size. As EM analysis already benefits from speed up in massively parallel processing, the time required for the mapping of the results in multiphysics calculation can become bottleneck. For this reason, the mapping for large-scale models in version 19.0 is also being sped up. This graph displays processing time for multi-purpose file export tool, and this results in a reduction of time required for large-scale model coupled analysis. And then the parallel solver function has been enhanced so that even when the rate of core usage is high, the effectiveness of SMP parallelization is guaranteed. When simultaneously running multiple analyses using SMP, the operating system could sometimes assign multiple tasks to one core, resulting in a degradation of the analysis speed. Now this will be avoided as JMAG have cores assigned specifically for each SMP calculation. The loss calculation in JMAG has been improved as the anomalous eddy current loss accuracy has been enhanced by identifying anomalous eddy current loss coefficient for each frequency. JMAG avoids the overestimation of loss due to the use of a single coefficient. So JMAG provides a tool allowing you to set these coefficients and the script to identify them. For structural analysis, nonlinear materials are now supported. The stress and displacement of a model when the yield stress is exceeded can now be accurately evaluated. JMAG and John Necke obtained the same results in this synchronous reluctance machine centrifugal stress study. And furthermore, in the structural analysis, the modeling of a contact has been improved and friction can now be accounted for. In rigid models, the nodes of contacting parts are shared and stress concentrates at those points of contact. When modeling the contact, however, stress largely occurs at the bridge part because the slip due to the consideration of friction. Correctly modeling contact will allow for increased accuracy in estimating stress. The zooming analysis has been enhanced. In the master model and sub-model analysis, there is no need for the boundary mesh and the time steps to be consistent with each other. Therefore, the master model analysis scale can be suppressed and the time can be reduced for the entire calculation. And in this example, the analysis time of the whole model has been reduced to 1/5. And in order to reduce time for the transient, JMAG also offers JMAG-RT to FEA switch. So before it reaches to steady states, you can use JMAG model. And once it reaches to steady states, you can capture the detailed transient better with the FEA model. And you only have to specify the number of steps you want to make the switch. And the magnetization ratio is shown better. Now let's check out the measure. The mesh is even more robust than in previous regions, especially for geometries that include misalignment or small shapes and faces compared to the size of the whole model. The mesh generation time for large and complex geometry featuring multiple curved surfaces has been reduced. By speeding up the solver along with the mesh generation, the time required for the whole analysis has been reduced. You can see how much improvement JMAG make each every 6 months. Between this is 6 months, between this is 6 months. And now comes the first demo. So JMAG allows mixed mesh. It can be well seen with this simple example. For example, if you mesh the magnet using a geometry editor and then import it to JMAG and together with a rotor, this is the simplest example for the mixed mesh. And then in the mesh property, you only need to check the preserve existing mesh and regenerate. Now we'll see the combined mesh. You can also apply skew on meshed models and more specified nodes using morphing function. And you can also delete the duplicate nodes, otherwise it will cause the matrix error. And now let's check out the pre-post processing feature improvements. With the introduction of the analysis parameter view, also known as APV, all analysis parameters and settings are compiled in a single screen. Let me show you the second demo. The APV is a new item in the study right-click Study Menu, Analysis Parameter View. In here, you can see everything that you used to do separately is combined in one single window. And you can uncheck if you think that is too much for you. And for example, if you would like to change the amplitude of the current supply, you can say 3-phase, type 3 TH, and then you can click this amplitude. Please note the amplitude is added in this area and this area by itself. And when you yeah, because I already have the result, that's why it's gray. And then you don't have to go outside of this window to run and load the result and view the result. Everything can be done in this same window. And once you click run, it will run all these results. And then when you load the result, it will load the result. When you say view all results, because I already changed the parameter, that's why I said no, don't save it. And then I have predefined the contour plot and flux lines, so only this will show as a result. Under displays the case, so that's the third case, step 1. I can change the step by moving the sidebar to see the animation, and I can also change the case. For example, I changed to case 4. I changed case 4, step 9. So this GUI has 2 windows. One is the APV, one is, you can call it ARV to show the result. That's the 2 new GUI window. And that's what is showed as dashboard in this presentation. And models with 3D and windings can now have their winding settings configured with ease, thanks to Winding Editor. Some of you might have used the 2D winding editor. It is especially very useful and save a lot of time if you have bar winding and with many layers. So that comes the third demo. So we start with a 2D. So basically you right-click a study and say add winding, and this winding will show up. It has 2 parts, region setting and winding setting. With the region setting, you basically only need 3 information: number of slots, number of poles, of course you know that, and then select 1 coil region, and based on these 2 information, it automatically capture all the rest of the winding regions. And then this is very similar to the express setup or winding setup window. You specify number of turns and resistance, and linked with this item in the circuit, then you specify pitch. This time I specify 6. Then you can see it is all automatically created. So in the end, you basically only specify this first winding. So that's the 2D case. I also have a 2D example I already set up. So first of all, JMAG has a tool it's a template-based tool. You can specify the parameters and JMAG will create this winding for you. It's called the coil template. You don't have to ask your CAD engineers to help you. It's very easy to create, and you can create much better, good looking. It's really like a CAD file with this coil template. And then once you have that coil with end winding, you can use the same winding editor tool, which support 3D with end winding now. Again, you have this winding diagram here. And again, in here, you only specify 1 coil. As you can imagine, if you have many layers and many slots, this will save you a lot of time. And the link to NX was done via Capri, and now JMAG has its own CAD link, can also do the same thing. JMAG also allows you to get more out of the flux lines, get access to flux lines length, coordinates, physical quantities on lines and line integral. Materials can now be assigned on an element-by-element basis. Sensitivity due to changes in geometry and material deterioration can now be evaluated with ease without the need to use geometry editor. So this operating time and complexity of the task are significantly reduced. The user interface performance in highlighting parts of or faces in material and condition settings, as well as display of node ID for large-scale model has been improved. As we already reduced solver and measure time for large-scale models, this is, again, one further step to reduce the workflow time for large-scale models. And the JMAG Remote System 4.0 has been released, and the time required for calculation processing time also reduced. And these are some material database changes. I won't cover these in detail. If you're interested, you can check on these improvements. And many of you are using parametric analysis optimization feature in daily basis, and I will introduce the key improvement for this. And the topology optimization, it is a very inspiring feature that gave you new ideas and innovation ideas for motor design. And JMAG already have NGNet-based topology optimization, and now it adds a density method. And now comes the fourth demo. I will show you can without any privilege. Okay, I need 2 lux barrier for both end of the magnets. This shows the topology optimization works. And of course, this one is, oh, sorry. This optimization is a multi-objective TA-based topology optimization. And see number of generation I use and population size, number of children. As you can imagine, this takes a lot of time. We do have a server, it's like HPC, and takes about a little less than a day to run this optimization. However, not everybody has that. So JMAG has a new method called density method. So with that, this is an example for the topology for the density method. So this one, see, I only have 11 cases. It runs very fast. You can run on your local machine. And that topology optimization is this another type, and you can set this. So this problem is you have a coil, there is some current flow through, so it generates a magnetic field around it. And this is the shield. This is has no material, it's just made of air. So we are going to evaluate the effectiveness of the shield. So what this shows is a continuous variable. What it means is the continuous variable distribution is showing the continuous variable. If it is 0, it means it's air region. If it is 1, it is the magnetic region. So it shows, oh, okay, 1 means you need this part, you need that to be the shield material. The blue one or purple one, this one is not really needed. at the shield. So you know, okay, that's the distribution of material out. Like, of course, in reality, you cannot make such a shield, but it gave you an idea where you wanted to put your material. And that's the last case. So that's the demo of topology optimization. And of course, when using the on-off topology optimization method like the NGNet, we can a physical boundary smoothing function has been introduced, so the boundary is not completely on and off. This helps the geometry looks smoother. And in some cases, when you have two or more studies, it's not necessarily both or more are EM analysis. It can be multiphysics, can be one EM, one structural analysis. And then sometimes you need to pass the result from one study to another study. Now you can do that in this new version. And then also for parametric analysis and optimization, you're not only limited to magnetic properties. You can use electric, mechanical, thermal, and iron loss. All these parameters can all be used as your for your optimization or parametric analysis. And now we moving to efficiency map. I believe this is a very interesting topic because even if you have your own code, you can still have this as a second opinion to compare to your own result. And also, it is very impressive how fast JMAG efficiency map runs. So you may even consider include this in your parametric analysis. So it's very helpful to know your design is good or not. And so JMAG has this feature in the last version already, but this version we added a generation mode. As you can see, this is for an induction motor. And we also allowed the loss breakdown for rotor and stator. So there it comes the fifth demo efficiency map. So for this efficiency map, as you can see, in these properties, you can choose under voltage limit and current limit, and you can choose the peak or fundamental voltage amplitude as your limit. You can choose between some control technique scheme, and also choose between motor mode only or motor generation mode. And basically you duplicate your study and then select the last one, efficiency map analysis. Then the efficiency map analysis is created. What you need to do is to populate the current, phase, and speed you would like to sweep and change the number of poles. And this currently support PMSM and induction motor. So once you run all these cases are run, you can create a map based on this response table that you get from that sweeping. So basically you have these three, sweeping the three parameters, then you get the average value for loss, for flux, for inductance. And the efficiency map is calculated based on those results. And you can export the result, and you can create, when you look at this point, for example, you can right click and add point, this point is added. And it confirms that at low speed, the copper loss dominate and high speed iron loss dominate. And then for accuracy priority, you have these points to simulate more accurately. You can add PWM effect control circuit, but sometimes it looks unconvergent or inconsistent compared to other points, you can right-click, go to case, and check more in detail. Now let's check JMAG-RT. So there is a new PMS model in JMAG-RT. It is called flux integration method model. So what this method model does, it uses flux instead of the inductance and flux like in the past. So as you can imagine, the number of matrix are reduced, and also, but however, the size increased a little bit. So in the end, you still get 50% reduction of the simulation time. And the Express has big changes this year. There are two things added. One is efficiency map, one is thermal analysis. Of course, efficiency map is always helpful no matter in JMAG-Designer or Express. It can help you to, from an early stage, to predict the machine efficiency if it's too far from what you expect or not. And then for this thermal equivalent method is it allows for quick temperature evaluation thanks to this thermal resistance circuit based on the motor geometry, and the obtained temperature will affect the characteristics of your model, which will be automatically reflected on its performances. And this is the list of documentation. So each page almost there is a reference like a thesis. So you can refer to these. W means white paper. It shows the theory, and the FT is function tutorial to focus more on a specific function. AC is application catalog, show you example, and has the application note, show you how the model is configured, what the conditions and materials, and the review of the results, and a quick analysis. So thank you so much for your attention.
Thank you very much, Simon. All right, so with this, we will conclude the presentation for today. But as I said, if you do have any other questions, you can always write back to us, or once we send the follow-up email, you can also reply to that with any questions or any requests that you may have. With this, we will end the presentation for today. I wish everybody please stay safe. I know this is a dire time out there, and thank you all for attending our first webinar of the webinar series. We do have a couple of other webinars coming up in terms of repeating the same topic and also some motor design courses as well. So please stay tuned on our website, and our sales team will get back to you with the list of seminars as well, which are going to be presented in near future. With that, thank you very much to all of you for attending, and stay safe.
Okay, thank you. Have a good day. Bye.